Okay, 9-8, solving quadratic equations by graphing. So we're going to graph these the same way we did with yesterday's lesson. But once we graph them, we're going to actually find the solutions to the equation. So we have an equation here. We learned to solve by factoring in the last unit, way before we left school. But now we're going to graph to find the solutions and talk about the different possibilities. So we're going to be able to find solutions to equations by graphing and estimate the solutions when we can't find the actual solution. There are three situations that can happen when we graph. We can have two solutions. It crosses the x-axis at 2 points. One solution in which it hits the x-axis and bounces back, or no solutions, it never touches the x-axis. So let's look at the different cases of what's going to happen, and then you'll have some practice to do on your own. So the first one, again, the first step in graphing is to find the axis of symmetry. So x equals negative b over 2a. Again, a is 1, b is negative 2, and c is negative 8. So we solve that. Negative 2 is positive 2 over 2 is 1. So on our graph, we're going to put our axis of symmetry at positive 1. And then our next step was to plug that in. So we go to our equation, 1 squared minus 2 times 1 minus 8 is 1, minus 2 minus 8 is negative 9. So we're going to go to negative 9 and put a point. Okay. So then we had the the y-intercept, so c equals negative 8. So we're going to put the point at negative 8 on our y-intercept and reflect it. And now we got to continue because we need to get the point that's where it's going to cross the x-axis. And right now we're down here, and we need to be very accurate. So we have two choices. We can use the pattern we had talked about in a while back in a lesson, in which we have, if we have a coefficient of 1, if a is 1, that's like the slope, that the pattern is 1, 3, 5, 7. It goes up by odd numbers. So we go up 1 and over 1, then we go up 3 and over 1, then up 1, 2, 3, 4, 5 and over 1. And we can do that here, up 3 and over 1, up 5 and over 1. And you can continue and go up 7 and over 1. And you can get this curve this way. So that's one option if you can know the pattern to make the curve and find the values. The other option is to plug in numbers. So we could go and we say, okay, well, we have positive 1. Let's plug in positive 2. And we have 2 squared minus 2 times 2 minus 8. And that would give me 4 minus 8, which would give me, hold on, so that would, we already had that point. Sorry, I should be plugging in 3. We already had 2. So 3 squared is 9. 2 times 3 is 6. 9 minus 6 is 3. Minus 8 is negative 5. So we plot the point 3, negative 5, and reflect it. And then we say, well, we still got to keep going. So then we plug in 4. 4 squared minus 2 times 4 minus 8. 16 minus 8 is 0. And then we get that point on the axis and we reflect it. So you can either do substitution or you can use the pattern. Again, if the pattern is if a is 1. So if a is 1, we use an odd number pattern, up 1, then up 3, then up 5, and so forth. So the solutions are the x-intercepts. So x equals negative 2 and x equals positive 4. So there are our solutions. Okay. So that's how we use graphing to solve. So let's look at the next one. In order to do any kind of graphing, the first thing we have to do is set this equal to 0. So we have y equals x squared minus 6x, then 9 comes over plus 9. Okay, and then we're going to do a is 1, b is negative 6, and c is 9. So step 1 is x equals negative 6 over 2 times 1, which would be 6 over 2, or 3. So we put our axis of symmetry at 3. All right, and then we're going to plug that in. So y equals 3 squared minus 6 times 3 plus 9. 9 minus 18 plus 9 is 0. So then that point is right at 0. Right? That's the vertex. So then we can do our y-intercept. C equals negative or positive 9. So we put our y-intercept at positive 9 and we reflect that. And if we look at this graph, we're trying to find where it crosses the x-axis. Well, we have our solution right there. So we don't have to do anything more. That is the vertex. So this has only one root because the vertex is on there. So x equals 3 is the only answer. Okay, so now we're going to look at a couple more examples of this. So example 3, again, A equals 2, B equals negative 3, C equals 5. So step 1, x equals negative 3 over 2 times 2. Okay, so we've got negative 3, which would be 3. 2 times 2 is 4. So the axis of symmetry is at positive 3/4. And so then we're going to plug that in. So 2 times 3/4 squared minus 3 times 3/4 plus 5. And we get 2 times 3 squared is 9 over 16. Minus 3 times 3 is 9 over 4. And if we do this, we get 18 over 16. If I make this out of 16, I'm going to multiply by 4. 36 and then plus 5. So this would be negative 18 over 16. And 16 goes in 18 once. So negative 1 and 1/8 basically plus 5. So we get 4, 3 and 7/8. So we go to positive 3 and 7/8 and put a point. And then if we go to, that's number 2. If we go to 3, C equals 5. And we put a point at 5. And we think about this graph is opening upward, which means it's never going to cross the x-axis. And once we realize that we don't do anything else because there is no solution. And we should really say no real solution. When you get to Algebra 2 in your junior year, you will learn about imaginary solutions, and then you will be able to do something more with this. And then the last one, it says no integral roots estimation. We're going to talk about what happens when it's not a perfect solution. So let's do this one. So number 1, A is 1, B is 6, and C is 6. So we have x equals negative 6 over 2 times 1, which is negative 3. So we put our axis of symmetry at negative 3. And then we got to plug that in. So negative 3 squared plus 6 times negative 3 plus 6 is 9 minus 18 plus 6. That'd be negative 9 plus 6 is negative 3. So we have a coordinate of negative 3, and we put that point. Okay, and this A is 1. So we're going to follow our pattern. So up 1 over 1, and then 3, and then 5. Up 3 over 1, up 5 over 1. And we can go this way, up 1 over 1, up 3 over 1, up 5 over 1. And if we draw that curve, what you'll realize is that when it crosses the x-axis, and let's see if I can highlight this point, when it crosses the x-axis, it does not cross at a whole number. It crosses between two values. For these, you're going to say x equals, you're going to say between, we don't know the actual value, it's between negative 4 and negative 5. That's the first place, and then x is between negative 1 and negative 2. So it's some decimal or fractional value. We can actually, if you were solving this, you would get a radical solution when you went to solve this. So it's just between, we don't have the exact value. So for these, if it's something between, you just put the two whole numbers that it falls between. Okay, so you're going to do the problems that go with this. I think there's 10 problems that go with this. There are 2 word problems that you should try best you can with. The other ones are all graphing. Make sure the graph is in standard form, the equation is in standard form before you graph. Okay.